because I don't appear on the screen. There we are. Perfect. Welcome to our next session about zero trust architecture and sovereign environments. My name is Max Körbecher. I'm one of the team members of the Sovereign Cloud community. We're trying to build a sovereign cloud, sovereign AI, sovereign data community to share knowledge, impressions, experiences, just without all of the other fuss, just providing a platform where you can exchange your source ideas and so on and so forth. If you have any wishes for topics, if you have any ideas, if you would like to discuss something, if you would like to present something, feel free to reach out on our email address or on Zulip or LinkedIn or wherever else. Drop us a message. We are super happy to have someone hosted on this platform. But today, zero trust is the topic. We have talked already on the last session about it, that zero trust is one of the relevant pillars for not only ensuring sovereignty, but also to provide a new security concept, new quote unquote, where it helps us to become more flexible, more dynamic, being more adjustable, which is relevant to not lock us even further down between all different kinds of compliance rules and all the other stuff which is out there that sometimes feels like it's blocking us from actually doing what we should do as engineers and providing services and solutions for the company. Sovereignty by itself doesn't solve all the problems which we might face and see. So sovereign cloud providers help us on the legal side to be GDPR compliant, to be compliant with all the EU regulations, EU acts, frameworks, whatever you want to mention here, and gives us also a certainty about data ownership. But sovereignty itself doesn't mean that it is secure, right? So we have to take part on the technical side of the spectrum of sovereignty about the security, the access control, the compliance to be implemented in a good and healthy way. The thing is that the traditional security, in my opinion, is actually dead. And that has less something to do with the effectiveness of some of the measurements rather than it is nailing or, providing to be movable, right? So in an old world, you have everywhere firewalls, but frankly speaking, most of the firewalls are more checking like, are you doing the right communication through the right port, rather than to really, really scan and have a web application firewall, for example. Often companies skip this part to save costs, be faster in the implementation. There's just within the parameters, but if you come out of this parameter, you do not know what to do with it. VPN for remote access, old but gold. I doubt it. And then we have network segmentation, which is often planned over months and years of projects before they are built somewhere. And after they have implemented, they're often not really changeable. Even if you have software-defined networking, even if you have software-defined firewalling. But the problem stands that the classical security model, which is implemented by often understaffed security teams, and I'm sorry to say, often teams that do not understand cloud or cloud native, is just trust but don't verify, right? And this doesn't work because the cloud native workload is way more dynamic nowadays. We have a lot of remote as a work standard for also how we work with people together. We have this lateral movement in breaches. So it's not just like, oh, there's one little thingy that happens. It's usually escalates very fast, very quickly throughout my entire network if you're once in. And the insider threats remain still undetected. And this is the biggest problem that you can have, that you have inside of your organization, inside of your company, people stealing your intellectual property, stealing your valuable data, and so on and so forth. There was just a report from the US government about how critical this actually is, that foreign forces send, well, it sounds like sci-fi, but it's sending female special agents into meeting and mating with people of certain roles to gather information and to gain access to tools. So it is there. It is a threat. And I believe in Europe, especially, we are somehow a little bit behind with our old and traditional, unflexible way of doing security. And then on top of that, we have the political imperative, right? We have one act after the other act. We have NIS regulations. We have dollar regulations. We need to ensure in some way that we are knowing who have access to what. We need to implement resilient cloud platforms, whatever it means. And we have to invest in security and in sovereign technologies to keep up with all those regulations. I see zero trust as an enabler to overcome all those political imperatives. I believe that if we build on zero trust first, we will easily skip, or we easily don't need to necessarily go too much down in all of the single regulations, because it will be solved. It will be way more resilient and will be way more secure than what we currently plan most of the time with very stiff security rules that are completely inflexible. So zero trust everywhere, but what means zero trust? Never trust, always verify. I think that's a saying that was a few years back put on a big stage, and I think since then it's stuck there. It has three relevant aspects, or three relevant pillars we have to look in. First, the identity. There's nothing special to normal security, but we want to know who are you. Then the device, from where do you access, and then giving us a context. And this is the most important pillar, I would say, because zero trust is looking into your context of how and where and why, through what, through which time, through which place you want to access or execute a certain element of your activities. What does it mean? Well, if I'm on vacation, I can still access our company systems via VPN, right? Should I do that? Well, in sake of the vacation, I shouldn't do it. And in sake of security, maybe I also shouldn't do it. However, in zero trust, this would not be possible because I'm on the wrong place, I have the wrong device, I'm maybe at the wrong time, right? So I'm a few thousand kilometers off, and when I want to try to access the system, it's like maybe night in my company original zone. So the context can be extremely complicated if you want to, but it gives a very certain profile of a person and can restrict very dramatically from where and how and when you can access it. But on the same time, if you go to vacation, you can just register it and say like, hey, I will be next week, I don't know, working from, I don't know, let's say Turkey. But it's fine that I'm accessing the system. So flexibility given, but it's not restricting us in our actual doing. And identity first is here the key that we really have to take a look at. The parameter of identity means not longer only to ask, are you in the right network, which we see in the most of the traditional security environments, that we're looking into the network segmentation and are you allowed to be in that network segment? Because quite often you have in one large network segment way too many applications that you can access. I forgot there to translate something, but the alternative or the question is, are you authenticated and authorized to do what you want to do? So we need for this a strong authentication. We need a good workload identity, least privilege access, and just-in-time allowance for accessing some tools, right? And this happen only if you're on a request base. Every time get proved that you are you and that you're the right person at the right time, accessing the right tool with the right action you want to do. How this usually happens is like when you are a user or a device or an application, after you have done the identity verification, you end up in the PDP, the policy decision point, that decides actually based on some policies that you have an access right to that tool. And for the next step, you have a policy enforcement point. So it enforces the decision, whether you're allowed to do it or you're not allowed to do it. It's usually a little bit separated because the policy decision point is more like try to understand what you want to do and try to match it against the centrally managed policy that is, for example, available in an administration point. And the enforcement can work on different multiple layers. It can work on the network, it can work on the application, it can work maybe on the request process in the system, right? So we have the control and we have the technical implementation of the zero trust, which is relevant here. So sovereignty and zero trust together become a very powerful tool, I would say, in times where we have to follow tons of complicated compliance rules, where we have to ensure data sovereignty and the ownership of the data, and be sure that not the wrong person is entering the wrong data in the end. We need to put it both together. In short, if we take a look on the zero trust or security at all, what we never want to do is, like, if an attacker is in an untrusted network, that they can access the workload in the network, but also not the network or the applications in another network, obviously. The reality is quite often that we have the left part of the picture, that if an attacker is in an untrusted network, he more or less can access almost every system there. There's a lot of mechanisms around it, on VMs, on bare metal, in the network itself, on Kubernetes, to actually prevent that. But security is quite often not there yet. And the other thing is that if an attacker once can access one part of the untrusted network as an application, it's quite easy to get forwarded also to another part. Not maybe by access rights, but by doing simple injections, simple queries, and retrieve information. Where we want to be, that's the right side of the story, is that every single piece in the network not only has a firewall, that's the stupid part, but is controlling what are you doing, when you're doing, how you're doing, for which reason you're doing, and so on and so forth. So it can be that you maybe in some case have luck to access one application, but if you want to access the other application, the wrong other application, you will be prevented to access it. And this is zero trust. I have never trusted you are you at the right time, place, blah, blah, blah. Right? And this is a very powerful mechanism because it's extremely fine-grained and it's extremely narrowed down to your profile and what you are supposed to do in your job. We once had a discussion with a customer about it, but yeah, how realistic is that this can happen? And I always give a very simple example. If you have a managing director of a company and he or she can access any kind of systems in the network, for which reason ever, but sometimes, managers, CEOs wants to do that, even if they don't need to. It means the person in their nearer environment can also do it, like their personal assistant, because they usually have access to everything, as a managing director has too. And while it's maybe difficult to bribe a managing director, even so Wirecard teaches us something different, the assistant is way more easier to bribe in this case. And I don't want to blame here someone, but this is just like how sometimes you have you extend your access boundaries to other people accidentally. With zero trust, your assistant might be, for example, able to use your email client and to forward emails to herself to take care about them. But it means that if she tries to access from your email client a link to any kind of application within your network, she will be prevented because, yes, the link comes from the managing director, but no, you are the wrong person. In traditional security, this most of the time will just work. So this will allow us to really simplify compliance. And this is for me, the most important point nowadays, because we have tons of EU acts, we have tons of regulations on NIS, on GDPR, on the Cyber Resiliency Act, Data Act, CIA Act, and so on. It's countless. With zero trust, you start on the policies, you going and nail it down extremely on a personal user base, on a process base, on task base. It's completely auditable. So it allows you to really realize such kind of complex frameworks in in a good, decent amount of time with extremely efficient results, rather than just to put somewhere, everywhere network segments, as an example. And this complexity reduction we can see through, if we change from like this network segmentation, it's still good to have some network segments. It's not about that, but planning network segments. Take care about VPN tunnels. They're often problematic and slow and doesn't work well. You have endless firewall rules. Your organization is extremely slow to adapt firewall rules. Even you have firewall as a code. I've never seen a company that is really fast in adapting to any kind of request. Uh, with demilitarized zones and trusted zones and air-gapped zones and whatsoever, you usually have an extreme high maintenance cost with a usually extremely understaffed department that is usually, and I know I say very often, but usually um, not very well aware of cloud capabilities, not very well aware of cloud native capabilities, and not very well aware about how to do that today. I do not want to offend someone, but it's quite often reality that there's no time for keeping up with all the speed. And so we keep doing the old things that are slowing down drastically. With zero trust, we have the micro parameter instead of macro parameter, means that we are looking into from a completely different perspective. We have a uniform security model that spreads out through the entire organization. That's also something that we see quite often. You have applications in an extremely critical segment, so there's a lot of controls, and then you have an application in an uncritical environment, and you don't care so much. The thing is, in the end, it doesn't matter, because if you have if someone leaks the information or whatever from the uncritical part, your company still will have reputation damage, and you still will be the company that got the data breach. It doesn't matter that the data is maybe irrelevant or is just like, I don't know, a bunch of very unimportant PDF files or whatever. But the thing is that you are unsecure and got breached. With the policy-based access controls and the centralized management, so you have a decentralized policy distribution that is centrally enabled, you can scale more or less unlimitedly. We'll talk later about a few tools, but some of them are built based on best practices from the largest IT provider on this planet. They scale to billions of users and requests at the same time. And we gain a performance advantage. So with all the zero trust implementations, we have intelligent routing, a fast routing. You don't need to go through VPN detours and stick on very slow connection. Sometimes then you're not allowed, you have to do another request and whatever. You're authenticated on the edge, right? Your device you have is your authentication mechanism. You don't need to first go to a system and call it and do something else. Every time you do something, you will be authenticated. This means even if you leave your computer completely without any observation and it's unlocked, which you never should do, but well, it happens quite frequently, I have seen. Every time you want to try to reach something, you have to authenticate yourself again. That might sound like a really big problem, but even if you just have to once or twice put your fingerprint on your MacBook or whatever, this is already enough to prevent that someone who has control of your notebook access to any critical system. And it doesn't need necessarily more time if you have to request or do this request. And yeah, with this, security doesn't have to be slow. That's the power again of zero trust. It actually solves a lot of problem, and it allows me to be fast and dynamic. So we have to overcome with zero trust a couple of challenges, right? So legacy systems are always difficult also to adapt to such kind of speed. The answer to it is that we can use proxy-based integrations with zero trust proxies in front of the app. Sure, there are ways to work around that if you really, really want it, but it's okay to do so. We have user experience that often might feel like, oh, we have now to do so many different authentication prompts, and it might be frustrating. There are solutions for internal SSO systems and session management approaches that will allow you to be kind of simpler with accessing all the time. Does this maybe weaken or soften the process? Can be. But as I said, there's maybe also a good possibility somewhere in between. So either you can use, for example, pass keys that you always unlock with your fingerprint or Face ID or whatever, which gives you always this one little half a second to authenticate. And then you have the operational overhead. We see that the policy management can be extremely complex if you start wrong. But policy as a code and a GitOps approach, having a central version system for it, is actually a key to it. It doesn't make it necessarily way less complex, but it helps me to at least have a control of the chaos and see what happens in the past and what can happen in the future. By the way, obviously, if you have questions, feel free to drop them into the chat so that I can answer them on time. Best practices, big bang, start small. It depends on. I think all of the ways are reasonable. Usually, zero trust means a lot of change in an organization, not for the identity provider part, right? A lot of these parts you will see in a company already available, not for the monitoring part. Also, I have to say here that we need to fine tune quite often the observability layer, because the zero trust means a lot of logging and audit logs going around. If you're not prepared, that end up very costly for you. But the main part happens in this policy design, with least privileges by default, understand the role-based and attribute-based and relationship-based accesses, and provide context-aware policies. I quite often hear here, like, if you have to define a policy for every person, it might take ages. But I think, again, that's also a little bit the wrong perspective. You can start on a higher level. So if you have a sales department, then you start with a sales role. If you have an HR department, you start with an HR role. And you very fast can differentiate between these different domains and apply a fine-grained model for each department. And from there, you maybe have special roles that you need to fulfill. So what do we can use to really implement zero trust architectures? And I have to say here, in the cloud native ecospace, there is a lot of solutions for it that are built on layer on layer on layer in Kubernetes. Now, not every organization has Kubernetes. That's also very well aware, but there's a few options how you can get around that. From the open source, we see the Spiffy Spire. Spiffy is a framework, Spire is a solution for it for the workload identity, which is very crucial for the zero trust for all the apps. We have an OPA, for example, as a policy engine. I'm personally not the biggest fan of it. I found it quite complex, but the benefit of OPA is I can put it everywhere. CI/CD pipeline, VMs, Kubernetes, serverless, it doesn't matter. You can put it everywhere as a policy engine. And then you have OpenFGA for relationship-based access control. Right? This can put you the context to who's that person accessing for which reason at which point in time, which kind of software. With that, you can create a very efficient base layer for zero trust. And again, combine it with a sovereign cloud provider, you will have a very strong powerhouse to overcome all of the different governmental compliance and regulatory frameworks. So, Spiffy Spire. Some maybe have never heard of it. It's a secure production identity framework for everyone. And the for everyone is the actual funny part in it, but they really try to come up with a framework that can be used by a lot of companies. It is a CNCF graduated project. It's actually quite wide adapted, and if you talk with the one or other more digitalized company, a lot of them are really using it, but it doesn't play always the biggest role because it's in some way kind of simple to use. So Spire, which is implementation of Spiffy, provides you with automatic workload identities, and you do not really to have to manage secrets anymore with it. And it gives you an attestation of the workload, so that you have short-lived certificates and the SPIFFE ID format will allow you to understand where does it come from, what does it do, and so on. And then Spire takes care in the background that this requests to each other are really allowed or not. OPA is policy as a code for zero trust decisions. And it's GitOps enabled. So you have a version control system. You can see which changes has happened. You just have to protect that a little bit. And you have a trustful environment where you can understand what's going on in your system and who has changed maybe which policies. You can see an example on the bottom how like a Rego policy can look like. So we can see that it's a very simple allow statement as an import token for the identity where it's service A. And everyone or the service, if it does a get request, can do that. That looks very simple, but you can do a lot of complex rules and policies here that in the end are extremely fine-grained for the access. The cool thing is it can scale out horizontally, as that can be put everywhere, but has a centrally managed policy repository from which it will pull policies. So that you can even ensure if you have a test system running in a CI/CD pipeline, for example, and doing the same request as you would do in a production, then the same policy can be used there too, right? And you can test it up front. OpenFGA, somehow, I think a tool which we should use quite more often. I really, really love it. It's currently in the CNCF incubating stage, and it actually has a good an idol it wants to follow, which is Zanzibar. Zanzibar is architected and developed by Google, and it can scale horizontally for billions of users and billions of requests without slowing you down. So whenever you make somewhere a login through Google or whatever else you do there, it continuously checks you in the background if you are allowed to do that. And sometimes you see that if you, I don't know, go into some administration settings, you're not allowed to do that. You will get blocked before even the website is loaded. So OpenFGA is therefore extremely powerful. It allows you this to define this permissions as a relationships, like we have seen before, similar to Spire for applications, but here for more on the user level, right? And it comes with SDK, so you can put it directly into your application. So there's less ways of working around, but it is detached from the permission model. So you can change permissions, but you don't have to change the code. How does it now looks like? Well, if you have, again, like a service A is requesting, we have the SPIFFE as the framework for it, and it checks if you can receive requests or receive a request to update an order number, blah, blah, blah. Then in the first step, SPIFFE will check if the service A is anyhow allowed to talk to service B, right? Because maybe it shouldn't. And then OpenFGA comes in if you are allowed with the SPIFFE identity to perform an update on that order. And when the check is successful, you will allow to do it. If not, then you will be blocked. And it can be so fine granular that you're maybe not allowed to do that on the order, or you may be not allowed to do an update, but just an add, and so on. The cool thing is that through this approach, you have central authorization logic, but it's decoupled from your business logic. So you can change both parts of the cake. You can change your business processes, but you don't have to really worry too much about the authorization logic behind it, because it can follow this principle, or you do it vice versa. Last but not least, we have to talk about service meshes, and I would not really recommend you to directly start with a service mesh. If you look into recommendations how to build up zero trust, you will always find the first recommendation, or one of the first recommendations, is like, if you use Kubernetes, also go with service meshes. Don't do that. Why? So service meshes are misused for a lot of different stuff. A misconception is that service mesh is the only way to use MTLS in a Kubernetes, for example. And that's just simply not true. You can use good CNIs like Calico or Cilium to do that too. Um, the other thing is it comes with the authorization policies, but it doesn't come with the authorization policies on a layer 7 for the sake of zero trust, but just to ensure that your requests which you are doing are really the right request for that application. Because service meshes are there for traffic management and have a fine-grained observability on how application performs. So this is more like a developer tool, helpful for developers rather than a security tool. However, it comes with a lot of security aspects, and that's why it's end up quite often in that entire domain. What I have to say, features from Istio, for example, also include that they can use Spire for workload identity. And that's very powerful because then you don't need to think about other approaches to integrate Spire or do it on the naked way. However, service measures, again, they can break your system entirely, right? We had once a case where a customer on a very large cloud provider enabled another service mesh functionality in the UI just to test it out. And then after a while, it was like, it doesn't work well. A few applications have a problem, so I want to take it out. Not possible. Huge problem. We have to just throw away the entire system, deploy it by new, and then we are back to good. So service meshes is really something you should have a look at and be aware that it's maybe not the best solution to get started with. So you see, I'm quite often talk about Kubernetes, cloud native, and zero trust in this context. This is because, again, like the Kubernetes community is extremely actionable in this case for security. Kubernetes by itself is very open if you do not really take care about it. And so it is helpful that you have a really strong security community that is taking care that you're not continuously expose any kind of your workload and all the other stuff. So why is it so perfect is that in Kubernetes you have massively distributed applications and user requests that are behaving very dynamic. So if you want to boil down this to network segments, you can do that around Kubernetes. You theoretically could do it in Kubernetes, but it's not useful because it's a dynamic platform. With tools like Cilium and Calico, you're very good to go for security purposes, and Linkerd or Istio as a service mesh can leverage you on this level to have a very easy workload identity integration, or you have to do it with SPIFFE Inspire by your own. And puts you in the case of MTLS everywhere to have a secure pod-to-pod communication. Now we see here often also discussions around it, okay, Max, but is it really useful that you have such high level of encryption and user requests and whatever within Kubernetes? And I would argue most of the time, why not? Like you literally do not lose that much time, and most of the systems are not that millisecond based request response driven as most companies believe it. Most human will not recognize. If you need 10 milliseconds more, so what? This is not what your brain is recognizing if it takes 10 milliseconds more. The other side of the story is quite often like, yeah, but I have classical systems and I have a cloud provider. How do I do it there? On the cloud provider level, it works a little bit differently. Like the major cloud provider, you see very strong identity access management, then you have firewalls, and you have other network elements, you have integrations for workload identity and short-living access between accounts, for example. This is all sort of zero trust. I have to say that I also believe that many of these features is more like to solve problems that if you would do it a little bit different, you would not need to have it. So you have, for example, this short-living access tokens between accounts in large cloud provider so that you can shortly go to another system and access it. The problem is just that you have too many accounts with too many applications, right? So that's why you have that. There's not so many other reasons why you really need that, except for kind of manual work. If you have workload identity, you don't need such kind of processes. It is also true that the sovereign cloud providers have a less advanced identity and access management. So many of them are really focusing on a user group, and maybe some project folders. You can work within that. You can use that to your advance. However, we quite often discuss like large enterprises wants more. I think that will come. And if not, you can put it on Kubernetes with your own setup, with Keycloak and OpenFGA and whatever, and just make it there, right? Then the sovereign cloud provider is just yet another very dynamic infrastructure provider, because frankly speaking, every cloud provider is just a very dynamic infrastructure provider with some managed services and some SLAs around it. We also should mention that we need some more tools, or that you see usually some more tools in the stack, from certificate management that helps us to automatically rotate certifications, to runtime security protections as Falco. We need a good open telemetry and Prometheus integration for scraping all the information from all the services, visualize somewhere, maybe creating events from it, which then is also relevant again for the policy itself. We need something to manage the secrets like OpenBow, and of course Keycloak for identity and access management. It's somehow have become a common pattern that you put somewhere in your organization a Keycloak, because it's easier to manage all the people and groups rather than in, for example, Azure Active Directory or Entra. So my last take for you is that sovereignty only works with security and zero trust. Sovereignty will, for the legal aspect, work without security and zero trust. But if we want to do it right, and if we want to do it good, then sovereignty initiatives come along with zero trust initiatives, so that you get both best out of the world. Neither sovereignty nor all of the EU regulations which you have around it should really slow you down. It's just that you should do it better in the end. And that's the approach which we, all the time should keep in mind if you once have set it up, integrating new tools and setting up new environments that follow zero trust best practices for you, for your organization, that become kind of simple. And then you give enough headspace for your security departments also to take care about other elements and improve granularity from steps to step all of your system, rather than be completely head underwater. All right. That's my message of the day. I will shortly check out the chats if you have any question in this regards. If you have any questions, please obviously drop me them into the chat. What are the best approaches to really get started? Yeah. Well, as I said, like best practice would be start small and build granularly on top of each other. I personally would start with building a good test bed in some way, where I would set up my ideal environment, where I would set up my ideal approach. And when I have this target picture, which I would love to have, then I can make a roadmap for myself how to implement that, because I have already made some learnings how to effectively implement zero trust. And with these learnings, I can then think about, shall I make a big bang? Shall I make an incremental improvement? Whatsoever. Nevertheless, most of the organizations have already the groundwork available. It's just more about leveraging them. As the identity access management, usually you have already everything what's needed on the user base. Quite often you have to sort it out and clarify a little bit something here, because usually organizations tends to have too much rights with people rather than to restrict rights. How do we can enable old systems, classic systems in banking. Um, Proxies. Unfortunately, the best way to implement them is putting very close to traditional systems proxies and forbid any other communication way, so that you always have to hit the proxy, which then does all the kind of authentication, authorization, the context awareness, and so on, and just routes the traffic further. The problem is more that quite often, especially in banks and insurances, you have this one massive system. So if you can access this one massive system, the doors are open. So um, that's more the challenge, that you need to think about how you can protect the inner working of such large monoliths. That's often the benefit if you talk about microservices. And it's not about cutting things into small pieces, but if you think about functional clusters, it's easier to isolate functional clusters. They all work together as one large application, but maybe not every user needs access to every kind of functional cluster within this microservices. Sovereign cloud provider do not provide me enough identity access management to really consider them as an option. Yeah, that's what I already said. So quite often, especially large enterprises, um, would prefer to have more capabilities in the identity and access management. However, I think if you go to a sovereign cloud provider, you maybe also need to rethink your entire cloud strategy in your cloud setup. For me personally, I always say the cloud is broken. We do in cloud provider IT like we did it the last 30, 40 years. We haven't advanced so much. We have new software, we have new servers, we have better performance, but everything else stays the same, right? We use the same old protocols, we use the same old network segmentation, the same old approaches to plan IT, also in cloud. And that's a problem, actually. And I don't want to blame again you, but it's really a problem of the end users rather than of the cloud providers per se. So if we talk about very simple identity access management, I would question, do we really need more than user groups and projects? Because you can write in this very simple policies that just two different users are allowed to communicate with each other, and you have suddenly the workload identity problem solved. If you build up a too complex project structure and spread 20 different accounts or 200 different accounts, maybe you should question the approach with all the accounts. And maybe you should think and reconsider if that's really the right approach to do, or if you should do something different here. With that, I think we are completely through. I would be very glad to hear your feedback, to hear your ideas and thoughts and experiences. Check out our Luma calendar. We will have in 2 weeks the next session about the open source and open source relevancy in sovereign cloud. Leave us some comments and points to discuss on LinkedIn, or write us an email, or join our Zulip server. I would like to have other people here presenting their experience, their ideas about sovereignty, about sovereign cloud. And also, we will set up for the December discussion panel we're currently planning, and then plan further content for 2026 so that we can start fresh with a new format also into the new year. With that said, I'm looking forward to get your messages and questions and ideas. And until then, I wish you already a very nice weekend and see you around. Thank you for joining for today.